Hi guys, hey, this is the video for lesson 2.4, which is on parallel and perpendicular lines. So as we can see here, we have our focus question: how can equations of lines help you identify whether the lines are parallel, perpendicular, or neither? And by the time the lesson's done, we'll be able to write equations for parallel lines as well as perpendicular lines. All right, so let's look at our first explore and reason. Graph the three equations using the tool, and we're just going to graph these by hand. So the first one is 3x plus 1. As we graph, we always start with our y-intercept. I'm going to pay attention to the scale as well as fill in some missing pieces here. So I'm going to go ahead and put in a 1 and a 3 and a 5 and a 7, as well as a 1 right here and a 3 here. So again, the first one, put a dot at 1 for the y-intercept and then a slope of 3. So up 3, 1, 2, 3, over 1, up 1, 2, 3, over 1. There's our first line. Change colors here. Let's do 3x plus 2. Y-intercept is 2. Slope is still 3 over 1. Up 3, 1, 2, 3. Over 1. Up 3, 1, 2, 3. Over 1. Do that again. Up 3, 1, 2, 3. Over 1. Up 3, 1, 2, 3. Over 1. There's my mistake. All right, so this line's sitting right here. And let's do one more. 3x plus 4. This time we're going to start at 4. Go up 3. 1, 2, 3, and over 1. That's enough to kind of draw that line. So, all right, so choose any pair. How are they related to each other? So we could say that they're all positive slopes. Say they're all going up and to the right. They have different y-intercepts. Most importantly, they have the same slope. Oops. Same slope slash they're parallel. And is it the same for every pair of lines in this equation? In this set, yes. Right? Everyone's a positive slope. Everyone goes up and to the right. Everyone had a different y-intercept. And everyone had the same slope and was parallel. Part C then says, write another set of 3 or more that have the same relationships. We have a lot of options here. We could do something like 2x plus 2, 2x minus 4, 2x plus 12. We could do negative 4x plus 2, negative 4x minus 8, negative 4x plus 10. Any of those would be sufficient there to have the same relationship. All right, so what is the equation of the line in slope-intercept form that passes through the point 8, 9 and is parallel to the graph of y equals 3/4 x minus 2? So the key here to think about is the fact that we know that we have a parallel line, and the thing that we need to know about parallel lines is they have the same slope. So I'm supposed to write a slope-intercept equation, which means I already know that it's y equals 3/4 x plus or minus something. But I know it's 3/4 x because I know it has to be parallel to this line here, which is also a slope of 3/4. So I have my x point, I have my y point sitting here. So I'm going to go ahead and just sub in the x point for x and the y point for y and determine what my starting value is. So let's go ahead and write this over here. I'm going to go 9 equals 3/4 8 plus b. And then we just simply evaluate. So 3/4 of 8 is 6. 6 plus b is supposed to be 9. I'm going to go minus 6 minus 6, and I get 3 is equal to b. So what is the equation? Well, we knew the slope was 3/4, and now we know the y-intercept is 3. All right, so write an equation to the line and slope-intercept from that passes through this point and is parallel to negative 2/3. Again, right off the bat, we know this is going to be y equals negative 2/3 x plus something or minus something. And again, what do we need to put in there? We need to put in the x value and the y value. My y value is going here. My x value is going here. So let's go ahead and sub those in. 5 goes in for y. Negative 3 goes in for x. And then again, it's plus something. This is 5 equals negative 2/3 times negative 3/1 plus something. That's 5 equals 6/3 plus 1, which is 5 equals 2 plus something. Subtract 2, subtract 2, and 3 is equal to b. So that means my equation was y equals negative 2/3 x, like we said we were going to start with, and then plus 3, because we got plus 3 right here. All right. Example 2, how can you show that two lines are perpendicular? How can you create perpendicular lines? All right, so when we talk perpendicular lines, we're talking about parallel lines that look like this. Perpendicular lines do cross, and they intersect and form a 90-degree angle there. No matter what they're doing, they're going to form a 90-degree angle, which is important because of the relationship in that slope. So how can we create perpendicular lines? Well, as I said, we're going to be looking for those right angles. That's an important relationship. And we're going to jump down to here to the slopes, because that's kind of the big piece here. So let me erase what I've got quickly here. Whoops, too far. All right, so let's clear this. So how do the slopes compare? Well, they compare, they're what we call negative or opposite reciprocals. Reciprocal. And by that, we might see like 3/4. The reciprocal of that is 4/3 because we're flipping the top and the bottom, and then we put a negative sign in there. So those are opposite reciprocals. Or if we see like 2, well, the opposite reciprocal is negative 1/2, because again, this would be 2/1. So if I flip this, it's 1/2, and then we put a negative sign in there. So that is how the slopes are related. If I have a line that has a slope of, let's just do 2. Let's say this is 2x plus 3. My perpendicular line is going to have a slope of negative 1/2. So this might be negative 1/2 x, plus 6. Again, the y-intercept isn't going to necessarily matter because we could have tons of perpendicular lines. I could have one down here. I could have one further down. I could have one further up. So again, this is going to change, but if my slope is 2, the perpendicular line is going to have a slope of negative 1/2 every single time. So why does it make sense for the slopes have opposite signs? Well, let's just draw these in quickly. Let's use that 2x again. Positive slope is going up and to the right. To get that right angle, I've got to change this, and I've got to have it headed this direction. Now I have a negative slope. It's going down and to the right. And again, that's going to be every single one of these. Now the y-intercept could be positive, the y-intercept could be negative, but that slope has to be, again, in this case, it's going to be negative 1/2. And that would be true if we went the other way, right? If we started here, we started with our negative slope. Let's say it's negative 2/3. It's only going to make sense that my perpendicular line, there's my right angle, is going to have a positive slope. And in this case, again, positive 3/2 would be my slope. All right, so what do we do with that? All right, what is the equation of the line that passes through the point 1,7 and is perpendicular to the graph negative 1/4? So we first pay attention to the slope, which is negative 1/4. So we know that the perpendicular slope, or the slope of the line that's perpendicular to this, of negative 1/4, is going to be a positive. And then we flip this, and it can be positive 4/1 or just positive 4. So once I know that, I can go ahead and kind of do the same process I always do, which is y equals 4x plus something plus b. Again, I don't really care that this one's 11. That's irrelevant. So now I'm going to take my x value and sub it in for x, and take my y value and sub it in for y, and see what happens. So this will be 7 is equal to 4 times 1 plus b. 4 times 1 is 4. 4 plus b is supposed to be 7. Minus 4, minus 4. 3 is equal to b. So y is equal to 4x plus 3. Is what we should have for that one. All right, what is the equation of the line that passes through the point 4,5 and is perpendicular to the graph of y equals 2x minus 3? Again, there's my slope. It's 2, or simply 2/1. Again, it's positive, so I know my negative reciprocal is going to be opposite. And I'm going to flip those two, and I've got negative 1/2. So that is my new slope. Again, this is my x, that's my y. So I know right now I'm y equals negative 1/2 x plus b. I'm going to sub in the 4 for x. I'm going to sub in the 5 for y. So I have 5 is equal to negative 2 plus b. Add the 2, and the b value is going to be 7. So we could say y equals negative 1/2 x plus 7. Or if we just had put this in point slope form, we could have said y minus 5 is equal to negative 1/2 x minus 4. So remember, y minus y1 is equal to m x minus x1. Either one would be fine. All right. So example 4. Are the equations 3y equals negative 4x plus 6 and y equals negative 3/4 x minus 5, parallel, perpendicular, or both. So the first thing I need to do is get this equation into point-slope form. So to do that, I'm going to take my original equation, and I'm going to divide by 3 across the board. So what I'm left with is y equals negative 4/3 x plus 2. And so now we can see that the slope in this first one is negative 4/3. You can see the slope in the second one is negative 3/4. So they are reciprocals, but they're not the negative reciprocal. So therefore, we don't have the same slope, so they're not parallel. We don't have the negative reciprocal slope, so they're not perpendicular. So in this case, it's going to be neither. And there's the error, right? You may confuse the slopes of perpendicular lines. The slopes of perpendicular line are opposite reciprocals, not just reciprocals. And that's what we see here. So we've got this one set up in slope-intercept form already. I have a slope of 2, and I have a slope of 1/2. Again, these are reciprocals. If I flip 2 over 1, I get 1 over 2. But I don't have that negative piece, so I have a neither. Let's see, in part B, I'm going to do some work to get this into slope-intercept form. So I'm going to first, I'm going to write this over here, 25x plus 5y equals 1. I'm going to start by subtracting 25x. Which leaves me 5y equals 1 minus 25x. Then I'm going to divide by 5. So I have y is equal to 1/5 minus 5x. So you can see our slope here was negative 5. Our slope here is negative 5. So we have parallel lines. One of them happens to start at 1/5. One of them happens to start at 0. But they are parallel. All right, example 5. A landscaper plans to install 2 new paths in a park. The new fountain path will be perpendicular to the east path. So we're looking at something like this and lead to the fountain. The new picnic path will be parallel to the fountain path and pass through the picnic area. So we're going to see something like that. So let's go ahead and get into the first thing we got to do is find the slope of our east path. So let's pick 2 points that are pretty easy to tell. I'm going to use this point right here, 0, 2. And let's go ahead and use this one, which is 5, 3. So we want to do the slope, which is rise over run. It looks like it goes up 1, and it goes over 1, 2, 3, 4, 5. So our original slope of the east path is 1/5. So we know that my parallel line will be 1/5. And my perpendicular line is going to be negative 5 over 1, or just negative 5. So let's do the fountain first. We have a point at 15, 2, and we want point slope form. So again, we know this is the perpendicular. It's going to have a slope of negative 5. So if we want this in point slope form, we're going to go y minus y1 equals m x minus x1. I have this as my x, this is my y, and I know my slope is going to be negative 5. So y minus 2 equals negative 5 x minus 15. and that's going to be the fountain. Now our picnic, you can see that we have a 0.5 comma 6, and I want to be parallel. I want to run this way. So I want my slope to remain 1/5. So again, we're going point slope form, so let's change colors to red. Again, this is picnic. So I know I'm going to be y minus y1 equals, now I know my slope is going to be 1/5. And then x minus x1, and now we can just sub in our point. There's my x, there's my y. So y minus 6 equals 1/5 x minus 5. And again, that's going to be the picnic. All right, the equation y equals 2x plus 7 represents the north path on a map. Find the equation of a path that passes through the point 6, 3 and is parallel to the north path. So we have a parallel and we have a slope. So remember, we're just going to simply go y equals 2x plus b, because I know my slope has to be 2 because I want to be parallel here. Here's my x point, here's my y point, so let's just sub those in. Y equals 2 times 6, because that's my x, plus b. 2 times 6 is 12. Let's subtract 12 from both sides. We get -9 is equal to b. So to get this back into slope, or into equation form, y equals 2x minus 9. Let's just find the equation for a path that passes through the same point but is now perpendicular. So again, our slope was 2. If we want to be perpendicular, we need the reciprocal and negative. So my slope is going to be -1/2. I still want to go through 6, 3, so I'm going to do the same process that I just did here. 3 equals, now instead of 2, I've got -1/2. I'm still going to put in a 6 plus b. -1/2 times 6 is -3 plus b equals 3. Add 3 to both sides. I get 6 is equal to b. So that leaves me an equation of y equals -1/2 x plus 6. All right, guys, that is lesson 2-4. Parallel, perpendicular. Remember, parallel, same slope. Perpendicular, negative or opposite reciprocal. If we get those two pieces down, we should be good to go.